Hi, everyone. Welcome. Can you hear me okay?
Yes, I can hear you.
Oh, thank you so much for answering.
Am I the only one here? I don't have my video on.
You are not, and I don't have my video on either, but you are not the
Okay.
only one here. It looks
Okay.
like everybody else is muted though, but welcome. I'm so glad you guys were able to join. Welcome to the OpenSimon Webinar series. For those of you who don't know already, OpenSimon is a learning engineering community working to improve learning outcomes for individual learners while collectively advancing our understanding of human learning. And this series is intended to consist of instruction, examples, and demonstrations of learning engineering techniques and tools, and to celebrate best practices in applied learning science for members of the community. So thank you guys all for joining. We have a nice crowd today, and today our topic is the Open Learning Initiative delivery and how you can use the Open Learning Initiative technology to deliver courses to and content to your students. I am Erin Serwinski. I am the Simon Initiative Community and Product Manager, overseeing the OpenSimon Toolkit technologies. And I have with me today Norman Beer, who is Executive Director of the Simon Initiative and the Director of OLI, as well as Hal Turner, who is our OLI partner and community manager. And so pretty shortly, I'm going to turn it over to Norm to take you through a presentation and talk through what you can get from Open Learning Initiative. So give us a moment as we switch over to some slides. And feel free, I'll be watching the chat, so feel free to ask questions in the chat room as we go along, and there'll be time at the end for Q&A as well. So without further ado, Norman, take it away.
Hi there. Thanks for joining us. I'm looking at the list of participants and noting some familiar names. So welcome. I think if you have heard me talk about OLI in the past, some of this is going to be familiar ground. Please feel free, as Erin noted, to interrupt, ask questions. I'm actually going to try to be reasonably brief in giving the overview of the Open Learning Initiative. Leave us a little bit of time for questions and discussion as we go. But just to get started, as Erin mentioned, I wear a couple of hats here at CMU. I am the Executive Director of the Simon Initiative, and I lead the Open Learning Initiative project. And most of the time, we found it helpful to talk a little bit about just what is that Simon Initiative thing. And so I wanted to give a real quick overview of Simon, and then from there talk about OLI and how it fits into the larger Simon Initiative. One of the things that is interesting about Carnegie Mellon is that we don't have a college of education. That has meant some interesting things. It means that there's no lone place on campus that owns learning science or learning research. And this has meant that when you combine this with what's really been a tradition of rich cross-disciplinary and cross-departmental work at CMU, it's meant that we've seen small centers and projects of excellence at that place where learning science and educational technology intersect. These kinds of projects have grown up over campus. And when we look back at this work, we really trace it back 50 years to some efforts that were originated with Herb Simon. Simon's best known for his work in economics and the Nobel Prize that he received. But in exploring organizational behaviors, Simon realized that he needed to better understand human beings, how human beings think. And this led him to really taking some deep explorations into what we now think of as cognitive science and learning science. Through his career, Simon remained really focused on and interested in improving education. And his own sense was that if we were going to take seriously the act of improving education, we couldn't focus on merely improving our performance as teachers, but that rather we needed to treat this question as a serious question of research, serious question of science, and to really drill in on that underlying scientific foundation. So a quote that we frequently use when we're talking about the initiative or OLI is this challenge that Simon put out to his colleagues, that if we're going to truly improve post-secondary education, we need to move from the solo sport of teaching to beginning to treat this as a community-based research activity, in which we think about that research as something that is as robust and as important as the work that we do in our own domains. 50 years later, we end up seeing a remarkable array of successful projects at that intersection between learning science and ed tech. This has ranged from OLI, which I'll be talking about, showing better learning results, to projects like our cognitive tutoring work. The field of educational data mining was essentially born here at CMU. So lots and lots of projects that are interesting and exciting here. But what we've discovered is that because we don't have a central home or a central college in this space, too often we're seeing these amazing projects not having the impact that they could make. We're seeing them not being fully used by Carnegie Mellon students. And we're often seeing this work not connect with and leverage previous findings. Even here, we're working very closely together. We see a lot of replication of effort. And so the Simon Initiative was launched as an umbrella over this group and this set of work to really provide better ways for accelerating and interconnecting it. As I mentioned, this is a remarkably diverse set of work. And so part of what we needed to understand is, how do we think about this as related? What is the underlying principle that represents Simon Initiative work, learning science work at CMU? For that, we've actually gone back to some of the early work of Simon, who really, as he thought about how to explore and understand learning, recognizes this as a thing that you can't see because it's happening inside of the human brain. It's a thing that, as a first step, if you want to study it, you need to get it out and to make it observable. And so he talks about this as a process of building models to represent that learning and to represent that learner. If we are able to take those models and then tie them closely to some kind of observable practice, this gives us the opportunity to refine and validate our models. And so an awful lot of our work is thinking about, how do we make these models observable? How do we make them actionable? What do I mean by a model? Because this ranges from really sophisticated and complex models of expertise to things that are a little simpler. And so in its simplest form, one way to think about a model as you're going about the act of designing a course is to be very intentional in connecting the skills that you want the learner to acquire with the activities that you believe are going to support them in acquiring these skills, and with the assessments that are going to help you to understand how well they've achieved these outcomes. And what we found that's interesting is the simple act of doing this kind of modeling will already start to tell you something about the model that you've designed and the learning experience that you've designed. So in this case, what we see is that it turns out we've got some activities that aren't explicitly tied to skills. We've got assessments that may or may not be assessing things that we're teaching. And equally as often, when you start digging in on this kind of model, you may find new skills that you hadn't been aware were a part of your course. And so from our perspective, the simplest model is a complete mapping of what are your learning activities, what are the skills that we think those activities are going to help students achieve, and how are we going to know when they've achieved them. So we can take that model and we use that as the place that we want to join what's happening in the learning sciences to what's happening in new innovations in practice, really being intentional in taking the best of what we know from learning sciences to design our new models, and from there, building out new kinds of instruction. Now, note that I talk about this as an innovation, and often creating new learning innovations means building out new pieces of ed tech. But in practice, we need not focus just on innovations that require technology. There are an awful lot of different kinds of instructional practices in the classroom that we also want to study. What's key from our perspective is that whatever the innovation, it's going to be instrumented. It's going to be generating the kind of data that allow us to observe the impact of this work, allow us to refine the model, and in turn to continue to refine and fine-tune this innovation. In the aggregate, we also want to be able to take these data, push them back to our colleagues in the learning sciences, and hopefully advance our understanding of how human beings learn. So here at CMU, we've been talking about this as a learning engineering approach. And, I think that there's been some interesting controversy around this term of learning engineering, and I think folks are coming at this with a lot of different understandings of what might mean to apply an engineering approach, and a different sense of what this implies with regard to instructional design. But from our perspective, this is what we mean by learning engineering. It's this close attention to what we can pull from the sciences. It's this observation of data and closing of the data loop, both in terms of improving the innovation and engaging back with our scientists on the learning science side. And so there is clearly an essential role here for instructional design and instructional designers. We don't see learning engineering as something that replaces or displaces the importance of the kind of abductive approaches we see from the design space. So the larger Simon Initiative then, our goal is to apply and extend and accelerate this learning engineering approach. We'd like to be better using it inside of our own house for our students, but we also recognize that the kinds of challenges that we see in the post-secondary space are not the kind that are going to be solved by one school. And so we really want to be able to get this work out in the world in a way that's going to have broader impact for learners and for our fellow scientists. We've been thinking a lot about how we want to accomplish that. And so one of the key moves that we've made over the past 4 months now, I guess. It's been 4 months already?
Yeah.
The summer has blown by.
It
Hopefully
has.
the rest of you had a summer that felt a little slower paced. But at the start of the summer, we were very excited to announce the next big project of the Simon Initiative, which has been the OpenSimon Toolkit. Our sense is that if we are serious about expanding the community that is able to participate in learning engineering, not just make use of these tools, but contribute back into the approach, then there's infrastructure needs. And the best way that we can do this is to really provide these infrastructural components. So what is the OpenSimon Toolkit? One way to think about the life cycle of educational projects is as a series of bad clip art that doesn't display very well on my laptop. Apologies. So when we think about putting the learning engineering process into play, we start off with that careful consideration of the activity that we want to build. We really want to be thoughtful in our design. From there, we want to be able to develop that activity in a way that is thoughtfully representing the design and is going to be able to be delivered out in the world. That delivery mechanism, whether that's something like the Open Learning Initiative with courseware or whether it's an instrumented classroom, needs to be able to capture information that can then feed back into our discovery phase. And so our goal with the OpenSimon Toolkit is to be able to provide a set of techniques, of tools, of content, and of the underlying code that can support this application of learning engineering across the entirety of this life cycle. And I think an awful lot of attention when we made our initial announcement about the toolkit has been on the code side. And we are really excited about the number of tools that we're releasing under an open license. But we think that thinking about this more holistically in terms of understanding what the techniques are that we're trying to get out in the world, how these tools support these techniques, and what some of the underlying instrumented content can be, ends up giving a much richer and more useful sense of the toolkit and of its potential application. And so the toolkit, in a lot of ways, is about taking a set of tools that gives you that full cycle and hopefully makes it easier to apply the learning engineering process. And we want to be able to not just push this stuff out into the world with an open source license, but rather to start to rationalize it a little bit and understand how do these different kinds of tools interconnect and work with one another, and how can we, whether using existing standards or creating new kinds of mechanisms, ensure that they play nicely and that new kinds of tools and approaches can get plugged in. And so our goal in making this larger toolkit release has really been as the foundation for a broader community of institutions and of educators who can both take advantage of, but also contribute back into this learning engineering approach. This should be in a way that's going to positively impact your students, but hopefully this will also be done in a way that it can have broader application as we continue to study human learning. All right. That was your intro. So this is the larger context for what we think when we talk about learning engineering, why we're releasing this toolkit as one component of an effort to more broadly see this work have impact. Let's talk about the Open Learning Initiative, because in a lot of ways we think about OLI as being an exemplar of this larger learning engineering approach. One of the things that's been interesting about being a part of and leading the Open Learning Initiative is how easily it gets siloed in the popular imagination into a small set of categories. I think folks often think, okay, well, OLI is just a set of course materials, or OLI is just the platform that delivers OLI courses. But when we think about OLI more broadly, OLI's goal is to be able to build rich online learning environments that apply what we know from the learning sciences, take advantage of technology in ways that can deliver a better learning experience while providing an opportunity to facilitate new insights in the learning sciences. So when we say an exemplar of the learning engineering approach, it's this intentional design of combining the best of what we know from learning with that ongoing research agenda. When we talk about the history of open education, and particularly the history of open education and its leveraging of the World Wide Web as a resource, an awful lot of attention is paid to the launch of MIT's OpenCourseWare project back in 2001. Really exciting time in which the Hewlett Foundation was trying to think about better ways to leverage technology in service of an access agenda. So with a pretty generous gift to MIT, they were able to launch OpenCourseWare, which at the time was conceived of collecting any kinds of resources that faculty were willing to share, whether these were lecture notes, videos, quizzes, exams, or sometimes entire courses, putting this stuff up on the web and making them openly and freely available. Sort of interestingly, this actually predates the use of the Creative Commons license, and so it's not even that the notion was that we were going to put it out there with a CC license at this point. It was just open and free access. This was really widely celebrated in the press, generated a lot of excitement, and led to some of the program officers, Kathy Casserly and Mike Smith, paying a visit to CMU and asking, hey, do you see what MIT is doing, and are you interested in taking some Carnegie Mellon materials and putting them online? And we said, no, not really. That doesn't sound interesting to us. Seemed to shorten the conversation. Mike and Kathy happened to be visiting us on September 10th. Their flight out was the next morning, and when they got to the airport, it turned out that there were no flights flying anywhere in the continental US. And so they were sort of stuck in Pittsburgh, needed to come back and spend a few days with us here at CMU. That ended up being a really interesting opportunity to take a deeper dive into what is it that we would find interesting. And I think what we wanted to talk with them about was this notion that we definitely care about an access agenda. Expanding access to educational opportunities is a core part of CMU's mission. It's a thing that we care about, but equally important in our minds is effectiveness. That if we're going to be releasing these materials and don't have any sense of whether they're effective or how to improve that effectiveness, then it's not necessarily a useful investment of time and resource. And so what we proposed was an opportunity to build on some of Carnegie Mellon's strengths in learning science, in how human beings use technology, and in being able to bring together rich interdisciplinary teams to explore this question of, could we leverage this then new World Wide Web and related technologies in order to demonstrably enact instruction? Could we take a careful evidence-based approach in our design of learning and in our evaluation of success? And if so, what would the impact of this be? They decided that this was interesting, and we were very fortunate to receive an investment to build out the first of the 4 OLI courses. And what we found fairly quickly, and maybe what seems not shocking now, but was authentic research at the time, is that yes, if you take a careful science-based approach to designing and improving learning experiences, you can demonstrably enact learning for independent learners, because that initial vision really was of students who were just out there somewhere in the world. However, what we discovered at about the same time is that we were seeing faculty picking up these learning environments, which in theory were designed simply for independent students, and beginning to use them in their own instructional practice. And we saw that they were able to change how they were engaging in the classroom based on what these learning environments were already providing to their learners. And so over time, that mission shifted a bit, not just to provide better online courses that can enact instruction, but also tools related to these courses that can support educators in the classroom. We continue to work towards sharing these courses and materials openly and freely, in part because of that initial access mission, But also because if we're going to be engaging in authentic research, we know that we must have a much larger community of students and of educators that are engaging in that work with us. But we also recognize that this is not work that can simply be housed at Carnegie Mellon. This is not it can't be Carnegie Mellon building courses for the world, because we're increasingly cognizant that all of these courseware projects and all of these larger ed tech projects have an incredibly important component around local context, around the learners that are using them, and around the environment that educators are supporting them in. And so we're looking to develop a much larger community of use of research and of development so that these new materials can be developed, so that existing materials can be revised and reused, put out into appropriate local instructional contexts, and hopefully helping us all understand how do different kinds of materials and approaches more effectively support different kinds of learners. So when we talk about OLI, we're not just talking about a platform, or we're just not talking about content, but we're also really advocating for a larger approach to designing, developing, and delivering these learning experiences. Science plays a key role in this, the application of the science of learning, but also taking a scientific approach to evaluating and improving these materials. We do leverage technology, but we like to say we can't let the technology lead. We need to let the learning context and underlying understanding of how learning works lead. Technology is there to support it. We take a team-based approach to development, and we're a little obsessive about data, about its capture and about its use in different ways. We like to talk about this design approach using a phrase that I've borrowed from my friend Dale Pike, which is learning design as hypothesis, that we want to be really explicit in stating what are the outcomes that we want students to achieve, and what is the sequence of activities that we believe will support learners in achieving that new knowledge state. By framing the question in this way, this allows us to evaluate that the validity of that hypothesis, which is a different way of approaching how well we understand and improve our courses. And this has a sort of interesting implication in that we really are building sequenced integrated learning environments. And I contrast that with a model of online education that, rather than having things sequenced and integrated, instead might have a collection of links for videos and a separate collection of links for exercises and another collection of links that points you to assessments. Within OLI, we want to bring you a student-centered measurable learning outcome, then provide some exposition to help get you into the course materials, and then immediately give you an opportunity to apply this new knowledge by answering a question or solving a problem. And it's this belief that this set of steps and these sets of activities will help support the learner in achieving what's been a defined and observable learning outcome. Baked into the system are principles that we're able to derive from learning science. And I think that if I were to boil all of the different affordances of the OLI platform down to one that was the most important, it's this notion that goal-directed practice and targeted feedback are some of the most important things we can do for learning. And so our system focuses, and our design process, frankly, focus on providing the student with as many opportunities as we can to practice their new skills, to give feedback that targets the misconceptions that they're demonstrating, to give them opportunities for help if they're not making good progress. And too often, I think, we get caught up in the idea that what constitutes great learning design or great ed tech needs to be exceptionally flashy and exceptionally sophisticated on the tech side. But in practice, even relatively simple on the technical side kinds of learning activities, down to multiple choice, can be pretty effective in supporting learners so long as they're well designed, so long as they are designed to call out these misconceptions and then give students feedback that's going to help them get past the misconception and get back on track. So one of the larger projects in the Simon Initiative is the Cognitive Tutor Authoring Toolkit, which is set up to allow you to build really rich, thoughtful cognitive tutors that are going to include both a domain model and a learner model. Cognitive tutors are incredibly effective, and we'll be having a later webinar talking about that toolkit. But there's a much bigger investment to be made in building out a full cognitive tutor, since you need to accommodate all of your possible learner misconceptions and all of their possible knowledge paths. We spend a lot of time in OLI building smaller embedded activities that we talk about as mini tutors. Our sense of a mini tutor is that rather than attempting to take a cognitive task analysis and completely develop all possible student misconceptions, we instead leverage faculty expertise and experience to identify our most likely misconceptions, and those are the ones that we want to address initially. This does mean that it's quite possible that we will end up missing some misconceptions, but since we're also committed to continuous and iterative improvement, we can recognize that, down the road, we need to be honest in evaluating how well did we get the student misconceptions, which ones have we missed, and how do we improve upon that in our next cycle. As I mentioned, we also see OLI as a place to explore new research questions. Here's just a quick example of one within our chemistry course. Dave Yearn, of our chemistry faculty, has had some ongoing concerns that within his chemistry sequence, too often by the end of the course, students aren't thinking like chemists, which in the end is his observable learning outcome. And he sees this as appearing in one form as students still using shallow ends-means analysis to solve problems. That they're working through a set of potential problems, they flip to the back of their chemistry book, find a formula that sort of matches onto the problem they're trying to solve, plug in their numbers, and if it works, they keep going. If it doesn't, they try a new formula. So he wanted to explore whether a more synthetic approach that used cases might help students in thinking like chemists and in moving beyond this sort of shallow ends-means analysis. And so he built out a set of course materials in OLI around stoichiometry that was built on a real-world case, water poisoning in Bangladesh. So real issue, which has had a real solution supported by the UN. That has been a set of filters that were designed by a local chemist that leverage local clays. So from the student's perspective, they're being thrust into this case where they have a local well that needs to be analyzed. They need to use the tools of the chemist to understand what is the level of poisoning, what are the other impurities that are in the water, and then to also explore the composition of the local clays. What's the filtration that's necessary based on this water work? And so this larger space gave him the chance to explore, does this instructional approach using a virtual chemistry lab help students, or does he need to go back to the drawing board? And this has ended up being a pretty successful and exciting project, both because the stoichiometry sequence has been used by lots and lots of learners, but also because it's given us this chance to embed a new kind of learning activity, and that is the virtual chemistry lab. As it turns out that one of the things that's necessary if you're going to be able to explore this space in a broad set of domains is the ability to incorporate new kinds of custom learning activities. So OLI supports a sort of base set of native activity types that are used for the kinds of embedded mini tutor opportunities that I mentioned. But we also know that we need to embed new kinds of activities, sometimes because that's what the domain of study requires, like chemistry, sometimes because these are the only ways that we're going to be able to more thoughtfully research the larger questions, and sometimes because we need more sophisticated kinds of activities to deliver synthetic learning experiences. On the back end then, OLI is very supportive of creating these new kinds of activities and plugging them in a way that integrates with the larger OLI data flow. I think that that's fairly important because that's what's going to enable some of the guidance we can give to educators, but also the information that flows back into the research agenda. I mentioned earlier, we take a team-based approach. Really like to recognize that there are multiple expertises that need to be brought to bear to develop these kinds of learning experiences. And so our goal in building an OLI course is often to not just take a single faculty member and quote, put their course online, but rather to engage with that faculty member with a larger team of experts to really try to map out what are the right learning outcomes, what are the sub-skills that constitute it, how do we understand the activities that get students there. We're often asked this question of what are the capabilities of technology to transform higher education? You get a lot of different answers to this. Folks who are very interested in scale, folks who are very interested in the ability of telecommunications to span lots of space. From our perspective, it's this ability to embed assessment opportunities across students' learning opportunities. And so we're very careful in leveraging learner interaction data and using it to drive feedback loops. One of the first is the feedback loop to the student, probably the most important, whether this is giving them targeted feedback for a specific misconception, or whether it's giving them feedback about their larger learning approach and successes. We also like to be able to provide feedback to faculty. One of the ongoing projects that we have at CMU has been around how we integrate these technology-enhanced learning tools into our instructional practice. And what you see on the screen is one example of this. So this is the learning dashboard. This is a tool that was developed by a pretty large team here at CMU, led by Marcia Lovett. And the notion behind this tool is that sitting behind every OLI course, we have a learner model, and we have a model of the course that includes learning objectives, sub-skills, some parameters around those skills. How difficult is this to achieve? How much practice do we believe students need to engage in before we can assume mastery? And these are tied to the high and low stakes learning activities within the course. And so as the students are engaging in activities, we are consistently making predictions on those students' mastery levels. You see on the screen then, students in the green are ones that we assume have mastered the course. We would predict that they would pass a third-party assessment. Students in the yellow are still working. Students in the red are still very early in their learning. And students in the gray, we simply do not have enough data to make a prediction. So it's important here to note that though we talk about this as predicted mastery levels, these are actually, in practical use, much more of a descriptive set of tools rather than a predictive set of tools. So we want to describe where we believe students' current knowledge state is. As a faculty member, I can assign this. So we're looking at a single module that I might have assigned last night. Before I walk into the classroom, I'm able to take a quick look and see what are the learning objectives that students are doing well on, what are the ones that they're struggling, and then drill down to see what are the sub-skills that are causing the most problems. From there, I can look at the questions students are answering, I can see the kinds of misconceptions they're exhibiting, and I can structure my classroom activities in ways that will really try to drill in on where the students are having trouble. Or if we're lucky and it seems like the course materials are really doing a great job of supporting the student, then we can use that classroom time in different ways, maybe to dig into some of the harder and thornier questions in the discipline. So on the one hand, we're very excited to be able to include tools like this dashboard in OLI, but we also recognize that my casual suggestion that you're going to look at this dashboard and then you're just going to quickly come up with some new classroom activities is making light of what's actually a really challenging part of our work as educators. And so we're really trying to think more deeply and seriously about how we support educators, how we make these tools actionable. So we talked about feedback loops for educators, feedback loops for students, but we also want to be able to leverage this data to iteratively improve our courses and to more broadly improve our understanding of how learning works. On the course design side, OLI integrates with a large number of tools to help us in improving our instruction. One of these is a tool called Learning Curve Analysis. It comes to us from the Learn Lab and in the Pittsburgh Science and Learning Center. I don't know how many of you have seen learning curves before, but sort of quickly go through this. And what you're looking at is a set of learning opportunities against a specific skill. And so in this case, what we want to look at is as students receive their first, second, third opportunities to solve these problems, how much help do they need in getting to the correct answer? So we talk about this as an assistance score, combination of hints that they request, and the number of questions that they get incorrect and thus get feedback on. What you see here is that early on, students are needing a lot of help, about 50% of the time. But as they get more opportunities to solve problems, we see that they need less and less help until, as a general rule, your students are consistently answering the question without assistance. This is a perfect learning curve. It's a thing of beauty. You are looking at what this represents, which is a really effective learning experience. But just as often, we don't always get learning curves that look like this. We instead get ones that show us that maybe our learning model that's represented inside of this course needs some additional work. And it could be that we're wasting students' time, giving them too much practice on things they already know. More often, we will see that what we thought was one skill turns out to be multiple skills. And so some of this work in analyzing and improving the course can be about teasing out What are these sub-skills that we're teaching? Are we offering enough practice for them? Other times we end up with mysteries where we see learning results that just don't make a lot of sense and require a much deeper dive. We've been engaging in some pretty serious investments around taking these kind of data and making them actionable for course improvements, really, whether this is focusing on instructional designers, whether this is focusing on faculty who are creating courses. How can we give information in the context of course authoring that will help support this course improvement work? Much of that is embedded in a different OLI tool. It's an authoring platform called Echo. And again, creating and improving OLI courseware is the subject of a future Simon webinar. But it's worth noting that the OLI delivery platform very explicitly is collecting and feeding information in ways that make this kind of iterative improvement possible. So wrapping around that, we also see, obviously, data that is made available for research purposes. I'm not going to take a deep dive into this question of data collection. I think there's larger questions there about how we go about collecting and securing information that comes from learners. But I did want to call out another important component of the OLI delivery platform, which is that it has been engineered with this explicit need for learner consent before student data are able to be used for research and for continuous improvement. And so this is a protocol that's been in place and that we've worked with our IRB on for years, and it really governs how student data can be used. They explicitly need to opt in to have their data shared in a de-identified way with OLI researchers. They're able to opt out at later points. And I think it's worth noting that this has been something that we've been thinking about and that we think is a really important part of this or any other platform that's going to be touching learner data. So this platform offers you an opportunity to apply the learning engineering approach to design and improve learning. We're really looking to leverage and expand learning science research. We take a team-based approach, and we are a little obsessive about data. What difference does it make? What does it get you? One of the things that we think we're best known for is probably our accelerated learning results. This is from the OLI statistics course. And we were comparing CMU students who were using the OLI stats course with students who were taking the traditional Carnegie Mellon face-to-face stats course. What we saw were that our students were completing their course in half the time and were showing more than twice the learning gains on a third-party assessment. It was interesting, and there was some concern that if students were learning this stuff faster, they may not be retaining it. So some subsequent research was able to come back more than a semester later and compare, finding that indeed there's no significant difference in how much knowledge they're retaining. This study is available from our website, but it led to some additional work because we wanted to understand, is this something that is unique to Carnegie Mellon students? Can these kinds of results be seen when we get these types of courses out in the larger world? And so there's a pretty exciting study that came out of Ithaca looking at this work in the context of larger public universities. So what I like to emphasize at this point when talking about OLIs is not is that I am not suggesting that any use of OLI courseware is going to lead to twice the learning in half the time, right? That's sort of ridiculous. Though we're excited that it has in this case. But rather, it's that time and again what we see is that this kind of approach with these kinds of tools are able to deliver improved outcomes for students while helping advance our understanding of how students learn. One of the more recent studies that we've engaged in, pretty lucky to be able to partner up with an institution that was offering a psychology MOOC. And they wanted to structure their MOOC such that they were providing the lecture videos and the high stakes assessments. Students were then using OLI as a high-tech textbook, essentially. And this gave us this interesting opportunity to dive in and understand what was the impact of different kinds of activities on their learning. You know, what's the value of watching a video? What's the impact of simply reading our exposition? And finally, what is the value of engaging in these richer learn by doing activities that are giving the kind of feedback I keep advocating for? This really sort of set up a natural experiment for us and allowed us to apply another tool that is part of the toolkit called Tetrad. So Tetrad offers an opportunity for building causal models, doing causal analysis, gives us an alternative to doing a more traditional fully randomized control trial. And so when we investigate the causal relationships between reading, watching, and doing, what we find in looking at those final high stakes assessments is that this learn by doing approach ends up being 6 times better for learning than either than watching the videos. We certainly learn a little bit by reading, about twice what we would be learning from the videos, but that impact on learning of the high stakes activities was pretty dramatic. And we've seen this at play as we've investigated this in a number of different courses. In some ways, this feels good because this is a validation of the OLI approach. But I think more importantly, it sort of leaves us asking, how should we be making our investments in the future when we begin designing online learning experiences? Frequently when we talk about these results in conversations, people say, well, I'm not surprised to hear that learn by doing is more effective than watching a lecture video. Isn't that just common sense? But the reality is that if it were just common sense, then I think we wouldn't have been spending so much time and money, millions and millions of dollars in the last 5 years, building online courses that seem to be primarily video-based with a little bit of text and a few multiple choice questions layered on. And so, one of the things that we're hoping by being able to drive this kind of research is to hopefully support the more thoughtful development of and use of technology in the learning process. And we've seen other class results as well. The use of our logic and proofs courses has really had a pretty interesting results in terms of helping with course completion. And so we're getting more students to the finish line and seeing those students complete at a higher rate of success. The stoichiometry course that I mentioned, the use of that lab and engagement with it ended up better predicting success than any other factor that we were able to investigate. We were lucky a few years back to partner with a lot of community colleges to build out and improve gateway courses. And the results of that research were showing that this use in the hybrid mode ended up being as effective and sometimes more effective than other approaches, in contrast to some earlier work that were showing that many community college students were challenged in the use of online courseware. And so all of this sort of brings us to this question of how can you work with OLI? So we are committed to releasing our platform under an open source license. We're going to be making it available under an MIT license, and that's going to happen in October. Most of the assignment toolkit has already been released. We have been slow to push the OLI courses out there, in part because they are so student-facing, and we really want to make sure that we've done a full code audit around our security components before we have the code out there for folks to take a look at. And so certainly being able to, whether this is running your own OLI server or contributing to the code base, is going to be an opportunity to work together. But in the immediate term, and indeed even over the longer term, we don't know that it's necessary for everyone to stand up their own instance of the OLI platform. We think that one of the places that we're all able to benefit is around shared resource and shared infrastructure. And so we're really encouraging a broader use of OLI, even with the platform that is sitting here, hosted at CMU. We currently have over 40 courses that are able to be adopted, whether that's picking up a few modules from them to address a specific learning challenge, or whether it's taking on the entirety of the courseware. And so definitely encourage leveraging of the courseware as it exists, and that includes both the content and the delivery mechanism. But as I mentioned, we've also been making some pretty serious investments in the customization and creation and improvement of OLI courseware. I think over the years, OLI has proven that they're able to be really successful in building courses, but that we've often gotten a reputation for having courses that are a little challenging to build, that our development process has not always been as friendly to educators as it might be. And so we've been really working to build out an authoring platform that doesn't require specialized expertise, that can really allow anyone to come in, build their own new materials, or take advantage of some of our existing open content, customize it. We're excited about this in part because we frequently hear that, as I mentioned with the statistics course, it's not always structured in a way that best speaks to someone's local student needs. And so if you think that you have a mechanism for better teaching mean and median for your learners, we want to now give you the opportunity to do that. Build out that module, let's get it in front of learners, and then let's see what the data says. And if it turns out that you really have a great way for teaching this subject to specific kinds of learners, then let's get that module back into the core canon. Let's make it available to a larger population. And if it doesn't show as good of results, let's try to understand why and circle back and take another attempt. So Echo will be going into in more depth, but it is available for anyone to sign up and create an account. It's also already available under an MIT license. And so if you head to the OpenSimon website, you're able to download and play with the code base in that way. Quick example of some of the Echo views. As you can see, we've been working hard at embedding some of those analytics to help as you audit your courses and then improve them. And obviously, we have ongoing opportunities to engage on the research side. As I've mentioned, OLI has the opportunity to integrate into or integrate with other kinds of learning experiences and learning activities. It also integrates with that larger Simon ecosystem. And so data from OLI is able to be moved into our educational data mining platforms, which in turn can help feed new kinds of research questions, be available for secondary analysis. And so that took a little longer than I intended. I apologize, but I think it still leaves us some time for questions. For future reference, if you need to get a hold of me, got my Twitter handle up on the screen. Turn it back over to Erin to see, do we have questions? Was this helpful? What else can we tell you that would be useful?
Thanks, Norm. That was great. I think it gave us a nice overview of OLI and its affordances and what can be done with it. I know I have a couple follow-up questions, but I'd like to turn it over to the group first to see if there's any questions from the audience. Well, I'll get us started then. So you mentioned OLI statistics. I'm wondering what other types of content is available already that can be delivered through OLI that's ready for people.
That's a great question. It's usually something that I touch on when we walk through the presentation, so thanks for reminding me. So our content is really all over the map. I think that there is often a sense that these kinds of delivery platforms with targeted feedback are only used or are best used in STEM domains. And I think that our goal has been to show that no, this approach can work in lots of different areas, and it's not merely in STEM. And so we see, we've got a great course in psychology. We've been running some really interesting courses around writing, or prose style course. I'm pretty excited about because we've been seeing some good results in helping students improve their own writing styles. The language and communication courses, so we've got courses across the modern languages, French, Spanish, Chinese, Arabic. We also have some courses clearly on the technology side. These include Intro to Programming, Anatomy and Physiology, Biology. Our Science College has been pretty active in working with us in building out new courses. We've got a course in e-learning design that we've been using as part of our master's program around learning engineering. And so I think one of the other exciting projects that's been going on here is an effort we're calling the Sidecar Project. We're really noticing at CMU, and we think most institutions are noticing, that we need to be better at teaching what we've been calling core competencies, and skills around communication, collaboration, team management. And so we have a few smaller OLI modules around collaboration and around conflict management that are intended not to be full courses, but rather to be plugged into a course that already has a team component. So Kelvin, hi Kelvin, by the way, I haven't seen you in a while, although I see you on Twitter frequently. I think that we would be delighted to have a larger, more public convening to talk about OLI, to talk about other Simon resources. One of our questions has been, what's the best form for that convening to take? So we have an annual program called Summer School that is intended as a one-week intense dive into what's become the Simon Toolkit. Folks show up with projects and spend the week learning about all of the tools, but really focusing on an individual project track, one of those being building OLI courses. And we saw our attendance this year roughly double from previous years. We think that as much as we know and love Pittsburgh, and would encourage everyone to come visit, that getting everyone to Pittsburgh is not always an option. And so we've been looking at the possibility of trying to set up some more regional convenings, whether this would be an individual institution hosting, whether we want to bring together consortia. We've also been trying to identify some conferences where we can be present. And so we're running a workshop at OLC this year, so we'll be down in Orlando. and we'll have some opportunities to practice with this stuff at OpenEd. And yeah, that's the question is, in addition to summer school, maybe we might start offering what we've been jokingly calling winter school. I'm glad to hear that there's interest, and hope you'll stay in touch and let us know what are the kinds of things that might be more useful to you and your constituents.
Definitely, and please contact me, reach out to me or Norman if you have ideas, or if you have maybe ideas for on-site visits, something like that. So we're open to a lot of different things. Yeah. Let us know what will work.
So Dan, I think that in terms of companies adopting the larger learning engineering approach and even adopting some of these technologies, I think that we definitely have seen organizations out there doing that. The one that is closest to home is a company called Carnegie Learning, who's really focused on taking a deep dive into the mathematics space, primary mathematics, particularly algebra, and I think there's a lot written about them out there. And they've been interesting in that, Carnegie Learning ends up being a very serious contributor of data back into Data Shop. That they've got a lot of information that's available for secondary analysis. And in fact, we've got a pretty rich corporate partners relationship, and so we see a lot of folks leveraging Data Shop, leveraging LearnSphere. In some cases, taking advantage of the Cognitive Tutor Authoring Toolkit. And sometimes the technology you might think of as flowing in the other direction. So one of the tools that is helping to drive that prose style course that I mentioned, obviously students need to be practicing writing and practicing revising. And we want to be able to give them some targeted feedback on that. We have ended up using a tool called Lightside Workbench, which ends up being a natural language processing and modeling tool that, because the faculty member that was involved had years and years of past student responses, good and bad, to the kinds of smaller writing assignments and revisions she was giving, she was able to use Lightside, part of the toolkit, to build out models and associated feedback based on those models. And so students, in addition to getting some generalized expert feedback, we also were able to use Lightside to apply and give them feedback that's a little more customized based on their writing. And Lightside ends up being one of the tools that supports Turnitin, which is its own source of controversy and is a place that we can be having a lot of discussions. But I think knowing that those underlying tools are available and are being used in multiple locations, is pretty interesting. And I think one of the places that I hope that we're all really cognizant of the dangers in technology and its use in applications in education is in bias. I think that, despite our best intentions, all of us are likely to introduce biases into the algorithms that we develop, into these processes that we develop. By making these tools openly available, we remove the black box and we're able to get more eyes on these. And I think that I don't know that that's the only way to start to address some of the biases that we see in these kinds of tools, but it's the best way that I know, that if we can be really transparent, get lots and lots of eyes on these tools, then this is one of the ways that we can start to ferret this information out. And so the Lightside Workbench is a great tool, openly available, both for use, but also for folks to dig in and understand how it works.
Thanks, Norm. I have another question. How easy is it for everyday faculty to take up and use OLI and get an account or deliver it to their students? I get asked a lot about, integration with LMSs and things like that. Mm-hmm. Is it pretty easy?
So we've worked hard to make it pretty straightforward. I think obviously the ongoing challenge is how you take advantage of this and integrate it with your teaching. And I think that that's a place where we keep working to bring together educators and let them form their own communities, because it seems as though it's used in different ways based on domain. But just sort of generally, it's very easy to jump onto OLI and create an account. You're able to request instructor access. We do verify that you're an instructor, because once you have access, you've got access to a lot of high stakes assessments that are less useful if your students are getting access to them. But from there, we've got a course creation utility that lets you create a customized section for your specific use, rearrange the modules that are there. One way from there to use the system is to have your students create accounts and log in directly to OLI. But what we've been seeing over the past 5 years is just an explosion in the use of LTI as an integration mechanism. And so we've got a fairly straightforward process for requesting a key secret pair for your institution. And from there, it's a pretty straightforward LTI integration path. And we've got a pretty good support team, part of whom is sitting here.
Yeah.
So we've got real human beings who are able to walk you through that as you run, if and when you run into challenges. So I think from the technical side, we've made it as easy as we can. There are always places where we can improve, and we keep trying to get better. But I've just been really pleased to see what LTI has given us so far on the integration side, and we are actively working to understand how we can take a better advantage of, no pun intended, LTI advantage and in our future work, because we think there's a lot more there we can be doing.
We have another couple questions here. So from Dan, you touched upon the advantages of CTA-based curriculums. What CTA protocols methods would you recommend for getting started?
Wow. You want to field this one?
I guess I'm wondering what.
Cognitive task analysis.
Right.
What's an easy effort into cognitive task analysis?
Well, it's a matter of really just observing students working through some tasks. I mean, I think on the easy side, in terms of, that's why we leverage teachers to build OLI courses, is because they've worked with enough students, they have that idea of what misconceptions are and how to build activities to address them.
So this, Dan, this has been an interesting conversation internally, because when we talk about this as a set of techniques, tools, content, and code, as we've started talking about application of different techniques, we've started to see that these end up being one of the places where there are gaps. And in fact, it turns out there aren't great tools for enacting cognitive task analysis. It's really a focused human process. So we've been working to push some more information on some of the approaches we take to CTA, which we're deriving from the e-learning design course I mentioned earlier. So we're trying to get some more information on this out on the web. I think that'll give you a chance to take a deeper dive. When all else fails, I recommend that folks grab a copy of MARE. And but I also think there's a nice coverage of some accessible CTA protocols in a text that came out of the Eberly Center. So our Center for Teaching Excellence and Educational Innovation, it's called the Eberly Center here at CMU. I think I mentioned Marcia Lovett earlier in this conversation. She directs the Eberly Center, but she and a number of her peers created a textbook called How Learning Works, 7 Principles for, I always just call it the 7 Principles book. 7 Principles for Better Learning? How Learning Works.
It's a great book.
And I think that there are a couple nice introductory approaches to research-based principles. So that'd be another place I would take a look at.
And I also want to say that as part of posting this webinar out online, I plan to also gather some documents that are related to this. So we'll be putting out a handout or talking points about OLI, but I could also dig into what's available around cognitive task analysis and add that to the same place so that you can dig in a little more easily.
Yeah, in terms of sharing the future of the OpenSimon toolkit, we are working hard at it. I think some of this has been about how do we develop communities around these open source tools and then share out roadmaps, needs, and so we've been taking some advantage of existing tools like Trello and GitHub, obviously. But part of our work has been in taking what are a set of really independent projects and getting them to start to collaborate and work a little more closely together, and sharing out those roadmaps is going to be a piece of that. But I think sort of more importantly is how do we take these roadmaps and these projects and move them from a space where we think of them as just CMUs and instead start to really see them as authentically being community resources that the larger community is contributing to and helping guide the development of. And so I think the answer to your second question is asking will other institutions outside of CMU be working with you to evolve these resources. I hope so. And in fact, I mean, I guess I would say more strongly that the Simon leadership team and the local CMU community is making a big bet that yes, that folks are going to want to engage with us in this way. That this is why we've been structuring the toolkit in the way that we have, because we think that it's going to be essential to have a larger community really start to take ownership of this work. And I think I said earlier in the presentation, but I want to reemphasize. I think that the challenges that we are seeing in education broadly, particularly in the post-secondary space here in the U.S., are too big a set of challenges for any one institution to solve. And so I think that the only way that they're going to be able to make progress on this is in acting as a community. And I think that a lot of these are problems that are appropriately the domain of not-for-profit higher education. And so I think that this offers us an opportunity to build a community that can engage thoughtfully with the broader educational sector, including industry, but can also really claim some part of this space and say, you know what, this is what we do in higher education. So yeah, so that's, I hope that answered that. That was a little bit rambly.
Well, I can let you know also that as part of the webinars, I mean, right now the webinar schedule is, I've figured out a number of webinars to hold about every other week from now to the end of the year that will be highlighting some of the tools in the toolkit. But as part of those webinars and through your questions that you're asking and the interactions we have with you all, I'm hoping to use that to formulate a set of more deeper dives in the next year, and maybe even some more hands-on type workshops through webinars that that will help involve you more and make sure we meet your needs and, as to how you want to use these tools.
Sarah, I'm going to grab yours as I think the last question. And it's a great question. And I feel like I keep falling back to say the larger Simon toolkit. But we see an awful lot of work being done in the K-12 space across the Simon initiative, and including with some of the tools that we've just released. Within OLI, over the years, our focus has been on higher education. And so we have fewer resources that have been developed that are specifically targeted to K-12. Not because we think the approach doesn't work, but simply because where our funding has driven us has really been in the space of building out larger and full post-secondary classes. That said, we've seen a lot of these courses be picked up and used in the high school context. Frequently in the AP context, we see our statistics and our biology and A&P used in those spaces. And we think that now that we have expanded the opportunities for being able to come in and make changes and customize, we expect that we're going to be seeing more use of this in K-12. Now, I think that there are some, K-12 comes with its own sort of challenges, and and I think that we're not always in a great spot to transfer some of the things that we're doing in higher ed, but we've definitely seen the resources used in that way. So Dan, I think that's a much larger and longer question. The short answer there is that there is an assumption on the part of both the dashboard, but I think on an awful lot of our tools, Data Shop and others, that you have a combination of robust data collection at the learner interaction level, and you have a carefully designed course that has some rich semantic context. And so, being able to leverage these systems assumes both of the context and the data collection. And so far, we haven't seen a lot of, we end up seeing missing pieces in a lot of the standard LMSs. It is possible to license the dashboard as standalone technology. That's something that I'm happy to jump on the phone and give you some pointers on if we want to talk in more detail.
Thanks, Norman, and thank you all for your engagement and great questions. I really appreciate it. We're over time, so I'm sorry for taking more of your time than we expected, but it seemed like a good subject. So I hope you'll join us in the next webinar. It's scheduled to come up in 2 weeks from now. They'll be held Wednesdays, same time. I'll get it out on the web and send out an email. But again, I can't thank you guys enough for joining us, and hope to see you again on these webinars. Have a great day.
Thanks all.